last class we have completed the problems based on determination of molecular formula and empirical formula. Today in this class we are going to start a new concept and we are almost at the end of this chapter. That is psychometry and psychometric coefficients, an important concept for your examination and for CET and NEET also. Let us understand psychometry and psychometric coefficients. Here this psychometry, the word is obtained from the two Greek words. Psycho means element, metron means measurement or measure. Simply we can say that psychometry means measurement of element. This psychometry represent or indicates the amount of reactant or volume of reactant required in a reaction and amount of product obtained in that reaction. Very simple. This psychometry helps us to calculate the amount of reactants involved in a reaction and amount of product obtained in a reaction. Yes. Let us take one example, one balanced equation, that is combustion of methane. If you take any hydrocarbon gas that undergoes combustion which gives carbon dioxide and water as a product always. If I take here the methane which undergoes combustion in the presence of oxygen which gives carbon dioxide and water as a products. These two are reactants and these two are products, and this is a balanced chemical equation. Balanced chemical equation means what? In the reactant side, how many atoms are there? In the product side, same number of atoms will be there. The mass of the reactants will equal to the mass of the product. That is law of mass action, and that is called balanced chemical equation. In this balanced chemical equation, we are going to apply the psychometry. That psychometry helps us to calculate how much of reactants will react in a reaction and how much of product will form in a balanced equation. Right? These two are reactants and these two are the products. Here, in this reaction, the reactants and products are represented by using a word, their physical state also. Physical state of these reactants and products are represented by using a symbol, as methane is a gas, so that's why it can be represented by G. Oxygen is also gas, represented by G. Carbon dioxide is a gas, represented by G, and water is a liquid, represented by L. In this reaction, you can also observe there is a 1. 1 is there, 1, 2, 1, 2. These are the stoichiometric coefficients, right? 1 for methane and 1 for carbon dioxide. These coefficients are called stoichiometric coefficients. And 2 for oxygen and 2 for water. These are also called stoichiometric coefficients. Stoichiometric coefficients means what? Those coefficients represent the number of molecules or number of moles involved in a reaction, whether it is product or reactant, right? That stoichiometric coefficient can be explained in 4 ways. Listen carefully, you can easily understand this one. In this balanced equation, this equation can be explained in 4 ways by using the stoichiometric coefficient, right? That equation can be explained in moles, right, or in case of molecules, or in case of volume, and finally that can be also explained in the form of mass, right? All these category can be explained with the help of stoichiometric coefficient. In this equation, what are the stoichiometric coefficients? 1 for methane, 2 for oxygen, 1 for carbon dioxide and 2 for water. This reaction must be the balanced chemical equation, then only you can consider their stoichiometric coefficients, right? Now I am going to describe this equation in the form of moles, right? Here the 1 mole of methane reacts with 2 moles of oxygen, which gives 1 mole of carbon dioxide and 2 mole of water. Right? We can also describe the equation in the form of molecule, right? This psychometric coefficient will also indicates the molecule, number of molecule, right? Here, the 1 molecule of what? Methane is reacts with 2 molecule of oxygen, which gives the product 1 molecule of carbon dioxide and 2 molecules of water. You can describe like this. You can also explain the equation if it is contained gaseous molecule. You can explain the equation in the form of volume, right? 1 mole of methane, we know that 1 mole of methane occupies how much of space, how much of volume? 22.4 liters, right? 1 mole of methane represents what? 22.4 liters of methane reacts with 2 into 22.4 liters of oxygen gives 1 mole of carbon dioxide occupies 22.4 liter of carbon dioxide and 2 into 22.4 liters of water will be obtained according to this volume. Right? And very lastly, you can describe this equation with the help of mass. Right? 1 mole of methane means how many mass? Obviously, it's gram atomic mass, gram molecular mass. 1 mole of methane means 16 gram. 16 gram of methane reacts with 2 into molecular mass of oxygen is 16. Right? 16 plus 16, 32. This much of oxygen and gives 1 mole of carbon dioxide. The mass of 1 mole of carbon dioxide means 44 gram of carbon dioxide will be obtained and 2 into the molecular mass of one water molecule is 18. 2 into 18 means that is 36. 36 gram of water will be obtained. Right? 16 gram of methane reacts with the 64 gram of oxygen, gives 44 grams of carbon dioxide and 36 gram of water. This is the way of describing the balanced chemical equation with the help of stoichiometric coefficients. Here the stoichiometric coefficients are considered only if the reaction is balanced. Balanced means what? The number of atoms present in a reactant will be equal to number of atoms present in a product. Right? I hope you understood. This equation can be described in these 4 ways. From this data, there is a relationship. If the mass of a substance can be converted into moles, moles of a substance converted into molecules, and again the molecules can be converted into moles, moles can be converted into mass of a substance. This is the concept. So with the help of this concept, let's do the problems, then only you can easily understand. Right? Let us start the problems based on stoichiometry and stoichiometric coefficients. Problem is to calculate the amount of water produced by 16 gram of methane. Calculate the amount of water produced by the 16 gram of methane. Very simple. First you have to write the balanced chemical equation. Right? That is combustion of methane. The solution will be, you know that any hydrocarbon gas undergo combustion which gives products carbon dioxide and water in the presence of oxygen, right? And this methane is combined with 2 moles of oxygen, definitely gives carbon dioxide, 1 mole of carbon dioxide and 2 mole of water. This is the balanced chemical equation. It is required for the problem, right? What they have asked, amount of water produced by 16 gram of methane. We know that This equation can be explained in the form of mass. 16 gram of methane is treated with the 64 grams of oxygen, which produces 44 grams of carbon dioxide and 36 grams of water, right? The first condition is the 16 gram, what they have given, 16 gram of methane produces 36 gram of water. Very simple. You can convert it into moles also, right? 16 gram of methane undergo combustion that produces 36 gram of water. Or you can also say that 16 gram of methane means what? 1 mole. 1 mole of methane undergo combustion which gives 2 moles of methane. Very simple. The direct question it is calculate the amount of water produced by 16 gram of methane. You can express it in grams or you can express it in moles, right? 2 moles of methane is obtained from the 1 mole of methane, or 36 gram of water is obtained from 16 gram of methane. Very simple question, and this is the answer. The amount of water produced by 16 gram of methane is 2 mole of water. 2 mole of water or 36 gram of water. Simple. Yes, the second question is, how many moles of methane is required to produce 22 grams of carbon dioxide after combustion? How many moles of methane is required to produce 22 grams of carbon dioxide after combustion? So first you have to write the balanced chemical equation. Which equation? According to the balanced equation is combustion of methane, right? We know that when methane is undergo combust with oxygen, gives carbon dioxide and 2 molecules of water. From this balanced equation, you can easily correlate the moles into molecules, molecules into moles, right? From the given data, from this equation, you can easily say that 16 gram of methane undergoes 64 grams of oxygen, gives 44 grams of carbon dioxide and 36 grams of water. By just calculating the molecular mass, you can easily say that, right? Here, I can write like this: 44 grams of carbon dioxide is obtained, right? 44 grams of carbon dioxide is obtained from 16 grams of methane. Right, clear? From this balanced equation, you can easily write like this: 44 grams of carbon dioxide is obtained from 16 grams of methane. Then they have asked a question: how many moles of methane is required to produce 22 grams of carbon dioxide? First, you have to calculate how much of methane is obtained in grams to obtain the 22 grams of carbon dioxide. Right? 44 grams of carbon dioxide is obtained from 16 grams of methane. Then 22 grams of carbon dioxide is obtained from how many grams of methane? Simple. First you have to calculate it, then you can convert it into moles, because they are asked in moles. Right? Just you have to cross multiply this data, you will get an answer: 22 gram into 16 gram divided by 44 grams, right? 2s are 2 8s are, right? 8 grams. Very simple. 22 grams of carbon dioxide is obtained from 8 grams of methane. Means 8 grams of methane is required to produce 22 grams of carbon dioxide after combustion. But they are asked in the form of moles. How many moles of methane? Right? 16 grams of methane. What we have considered 16 grams of methane means 1 mole, right? 1 mole of methane means 16 grams. Or 16 grams of methane means 1 mole. What about 8 grams? 8 grams of Methane means 16 gram of methane equals to 1 mole. What about 8 gram? 8 gram means half of it. 8 gram of methane. You can take it as 0.5 mole. Right? Simple. So 0.5 mole. How many moles of methane? 0.5 moles of methane is required to produce 22 gram of carbon dioxide after combustion. And this is the solution for this question. Okay, understood? Yes. Yes. The next concept is limiting reagent. As I hope you all know that in a chemical reaction, in a balanced chemical equation, it contains more than one reactant, two reactant or three reactant. If the reaction means it contains more than two reactant, right? Out of those reactants, one reactant is present in a large quantity than the others as required in a balanced equation. And in that balanced equation, for example, A plus B, these are the reactants, and C plus D, these are the product. Out of these two reactants, one reactant present in a large quantity than the other, and these products are produced. The products are produced on the basis of that reactant which has reacted completely, right? I hope you understood. For example, A and B. If this A, this reactant reacts completely, in a reaction, the reactant which reacts completely called as limiting reagent. Right? And those reactant which is not react completely called as excess reagent. Right? Excess reagent means what? The reactant which is not react completely called as excess reagent. In the reaction, the reactant which react completely called as limiting reagent, and the product and the masses of the products are obtained completely depend upon the reactant which has react completely, that means limiting reagent. The products are obtained or depend on this limiting reagent only, not on excess reagent. To understand this, I'll give you an example, then only you can understand, right? Consider one chemical equation, balanced chemical equation. H2 plus O2, 2O2 gives rise to 2H2 plus O2 gives rise to 2H2. As is a combination of hydrogen and oxygen which gives the water. This is the balanced chemical equation, right? Here we have the data before the reaction. Before the reaction, hydrogen is 10 mole, oxygen will be 7 mole, and before the reaction there is no formation of water, that means water will be 0 mole. After the reaction, right? After the reaction, hydrogen consumes completely, that means 0 mole. After the completion of this reaction, the concentration of hydrogen will be 0 mole. But oxygen will be 2 mole and water will be 10 mole. Right? This is the data they have given, and they ask a question. In this reaction, there are two reactants, hydrogen and oxygen. Which one is the limiting reagent and which one is the excess reagent? Right? By using this data, you can easily find out which one is limiting reagent. From the definition, I already told that the reactant which reacts completely in a reaction called as limiting reagent, right? You can observe here, before the reaction there is a 10 mole of hydrogen. After the reaction there is 0 mole of hydrogen. It means the hydrogen is reacted completely with 5 moles of oxygen and 2 moles of unreacted oxygen will be there. and which gives the product 10 mole of water. 2 moles of hydrogen combines with 1 mole of oxygen gives 2 moles of water. That means what? 10 mole of oxygen combines with 5 moles of oxygen only. The 2 moles of oxygen will be remain as such. Here the hydrogen is considered as, because it reacts completely in a reaction, so that's why it is considered as limiting reagent. Hydrogen is the limiting reagent in this reaction. Oxygen is the excess reagent. This reaction stops after consumption of 5 moles of oxygen and no further moles of hydrogen is left to react with unreacted 2 mole of oxygen to give the product. So that's why hydrogen is the limiting reagent, oxygen is the excess reagent. I hope you understood. Very simple concept. Limiting reagent means in a reaction the reactant which reacts completely called as limiting reagent, and those reactant which is not consumed completely is known as excess reagent. Right?